All right, what we're going to talk now about is ionization energy. And you do need to know these definitions for your test. So make sure you memorize them. Ionization, so ion is in ionization, and ionization energy is the energy that's required to remove an electron or become an ion. And there are different types of ionization energies, but basically they make perfect sense. We have the first ionization energy, and that's the energy required to remove the first electron. We have the second ionization energy, which is the energy required to move the second electron. And the third ionization energy is the energy required to remove the third electron. And just to note, every time you add or take away more and more electrons, it gets harder and harder, no matter what position or what element you're talking about. The first energy, or the first electron to be removed is always easiest compared to the second, and the second is always easiest compared to the third. All right, looking at this ionization energy table, remember, it's how much energy it is to remove an electron. So whatever this unit is, I actually have no idea what the energy unit is in this table, but looking at just the numbers, hydrogen only has a first ionization energy. And when you look at it, that's because hydrogen only has one electron. And so to remove that, it will not have a second electron to remove. So that would be 1312, whatever number or unit that means. Now we're going to look at helium. Helium, too, has only 2 electrons, so that's why it doesn't have a third ionization energy. You can't remove the third electron because it doesn't exist. But if you compare the first to the second, it is a lot harder to remove the second than it is the first. Now, the key one is to actually look at, for example, lithium. Lithium goes from 520 to 7,297, and that is a huge jump. Why? Because if you look at lithium, lithium only has one valence electron. Okay, so it can either gain 7 or lose that 1. Well, what is lithium going to want to always do? Lithium will always want to lose its one valence electron. Why? Because if I drew its energy, right, here's it, lithium that's the nucleus. And if I'm going to draw lithium totally, these are its two electrons in the first energy level, and this is its third electron, which only means that it is one valence electron in its outermost energy level. So what does it want to do? It can either lose that 1 or gain enough to make it have 8, so it would need to gain 7. Well, it's going to try to lose that 1. Why? Because as soon as I lose that 1, it now has a full octet, or in this case, it would be a duet. Why does it go so much more, though, to lose its second one? Well, because right now, lithium wanted to lose that 1, so it was full. Now it is perfectly happy, and you better put a lot of energy in it to make it lose that second electron. Why? Because if I lose that second electron, now it is not a full duet, full octet anymore, and it's no longer happy. So that's why you'll notice for beryllium, beryllium has 2 valence electrons. So when we're looking at beryllium losing its first, it's 900, its second is about 2,000, and then its third one, meaning that it too is going to be now no longer happy, is 14,000, almost 15,000, whatever, once again, that unit is. So obviously the ionization energies go up a lot more as soon as it's already hit that wonderful octet duet or full valence electron shell to remove any more from there. All right, the general trend going down is that it decreases, and the reason why is that these electrons are, if you remember back to the influences, the electrons are further out, and so therefore they are not as attracted to the nucleus as the ones that are closer in, so therefore it is easier to remove. The less attracted you are to something, the easier it is to stray or be pulled off. The same trend goes as across. As you go across, these electrons become more and more attracted to the nucleus because your nuclear charge is more, meaning you have more protons. So they are more attracted to these electrons. So therefore, it is going to be harder to remove. Okay? So as you go across your period, it becomes harder to remove those electrons. So therefore, your ionization energy, or the energy required to remove one of those electrons, increases. And here's the general graph of this. As we've described, it increases as you go across, it decreases as you go down, so it increases as you go up. So your most the highest ionization energy is He. So I always think IEHE, IEHE. All right, so that's it for ionization energy. Remember, ionization energy is the energy required to remove an electron, and you've got first, second, third, so on and so forth. But the one that has the highest ionization energy, I remember IE is He. Okay, so He has the highest ionization energy, and anything close to that will have higher than ones that are further from He. Have a great night.